Hey guys, Tater here, welcome to Tater Games. Today we're going to be creating an awesome game called Minigolf. Have you heard of it? It's all made in 2D, it's all very cool and incredibly easy, only using one script. So we're going to get straight into that after a little message from Moa. So because of this and because I want to start doing this a little bit more professionally, I've started up a Patreon account. Of course, if you want to go and visit that, link for that should be at the very top of the description below. As well as supporting this channel, you also get your name plonked up in almost every single video, and we already have one patron, which is awesome. So I'm going to plonk his name up right here. Thank you very much, buddy. You're doing well. As well as that, you also get access to a private Discord server labeled Tater Games Gold Squad, which is basically a whole bunch of people who can get together, and of course I will talk to you guys more directly within one chat channel. It's basically a way to directly talk to me instead of these DMs, because I can't answer all the DMs, but I can control my thoughts on one chat channel, which I think will be very handy indeed. As well as all that, you guys also get access to every single script ever made on these Sunday videos. Of course, using the channel inside the Tater Games Gold Squad if you want to do that, and I will definitely send it over your way. So if you guys want more direct help on your projects, or you guys want any script made in these Sunday videos, or you guys just want to help support the channel because you like these videos and they do help you, it would be very much appreciated if you go and support me on Patreon. Once again, link down in the description. Let's get started with the video. First things first, let's take a look at the entire game in its entirety. It's called Pixel Golf. It basically runs with a whole bunch of sprites. This is the first time I used a very cool tile map system, and hopefully you guys actually enjoy the game. One of the greatest features about this game is that it entirely runs off one script, and it's basically just the ball script. So you can make the entire game with just the ball script. Of course, you have menu changing and stuff like that, which I've also added just so we have something a bit more smooth and a bit more publishable for Google Play. The entire thing comes with finger dragging, so you can drag and then shoot your ball wherever you want, and of course if it gets in the hole, you're good. Right, let's start off with creating the look and the sprites of the actual game. You'll be surprised, the entire level is actually only made up of two kinds of sprites, and these sprites are both about 10 pixels by 10 pixels. All of which were made in Hexels 2, which you guys all know because I use Hexels 2 for basically every single game I create. Now, this is the first time I've used the tile map correctly. I actually have 3 layers on the tile map. I have one for the water, I have one for the grass, and of course I have one for the walls. Once all of them are imported into Unity, we of course set the order in the layer to 0, -1, and of course -2. The reason why we do that is because we want the grass in front of the water and we want the walls in front of the grass. Of course, we can open up our tile palette, drag all our sprites into there, and then of course put them and paint them onto our actual scene. Awfully handy. This new tile map system is boss. It is seriously going to change the way I make any single game from now on, because I'm going to basically run them as a tile map from now on. It's very easy to also add collisions to this whole thing. If you guys want to add collisions, you basically add a new component. The component is called Tile Map Collider 2D. Now you can of course use composites or effectors or some stuff like that into the actual colliders, but for this I didn't. I just left it basic, which means every single tile has its own little collider on it, and of course if the ball hits one of those colliders, it's probably going to bounce off the way that we're going to create this. So after drawing all the walls on this layer with the actual collider, we want another layer without a collider, because this is going to act as the grass. And the way I do this was to use the tiles that I already had but recolor them inside of Unity. The way you do that is basically by selecting the tile map game object, and of course there is a little color selection there, and you can change that to a sort of green. So now when we paint, everything we paint is going to have a green tint to it, which is very awesome because grass is green. So inside we've given the illusion of a top wall by making a darker part in the very bottom of our actual tile. But there's something cool we can do with this. We don't need to re-import anything to cast a shadow. We can actually flip this upside down using the square bracket keys. You tap the square bracket keys twice, it actually rotates it in a perfect 180, and then of course you can place it up the very top to create a nice looking shadow. Finally, for the bottom layer, which is the water layer, I did the exact same thing, just made it blue, which is really awesome. Now to save on rendering, because tile maps probably can handle a lot of this, which is perfectly fine, but I didn't want to go and draw all the water in, so I just made the background color the same color as the tiles for the water layer. And that's basically it. We can drag in some game objects, of course, so we can use it as a ball in a hole, and just set it where you like it so that we got our starting point of how we're actually going to make this game. First things first, the hole has no script. The world has no script. Nothing else has a script except for that ball, and of course, yeah, there are other things, for example, the camera, but we use the camera in the exact same way. It's the shortest script in the world. This .transform.position is equal to vector2.lerp, and then of course you give your current position, you give your ball position, and then of course you give a speed at which you want to lerp it at. This way we can move our camera with our ball as of course it moves around this world, but in a very smooth fashion. Call it the tracker script because it basically tracks the ball, and in any future video I'm not going to even mention this, I'm just going to say tracker script, so keep that in mind for you early viewers right now. Now let's go into the scripts of the ball. You need a little bit of mathematical knowledge to be able to to understand how to do this, but I should try and explain it very easily for you guys, and I'll try my best to do that. The first thing is first, we need to be able to actually aim our ball around the place, and the way I used this was to get the touch position, but instead of using the conventional if input.getTouch type thing, we're actually going to use input.getMouseDown. Now, it doesn't really matter what you use, they both work on mobile, and they also both work on PC, and they work on iPhone, and all of that type of stuff, but for this tutorial, I've actually decided to go with this because it was significantly easier to test. My phone wasn't working with Unity Remote. First things first, I made a boolean, which basically dictates whether or not I'm aiming, or whether or not I'm firing, or whether or not I can actually aim. For example, when the ball moves, I don't want to be aiming whilst the ball is moving. We need to wait until the ball is stopped before we make our next move. So the way to sell this effect is to create a boolean, and then of course you make an if statement detecting whether or not your finger has actually reached the phone. But of course we don't want this to happen anytime we touch the phone. We only want it to happen once the ball has 0 velocity, and the way we check this is this.get component rigidbody2d.velocity.magnitude is less than, and I put 0.1f, and the reason I put 0.1 is because we don't want it to stop completely. If it stops completely, that's actually a very bad sign, because sometimes the rigid body can still be moving even though it doesn't look like it's moving, and you want to sell the illusion. It doesn't need to be that accurate. And then of course I set the ready bool, which I created earlier, and this is basically to test whether or not we're ready to fire. That's all the information it really holds. So we set ready to true if it's less than, and of course we set ready to false if it's greater than, meaning that we are only ready once our velocity is stopped. Then of course we create another if statement detecting whether or not our finger has gone down and we are also ready, and the way that we do this is to write this: if input.getMouse button down 0 and of course is equal to true, and we are not aiming and we are ready, then aiming is equal to true. Of course now we can make an if statement in the update function about the actual aiming, and this starts like this: if aiming bracket. Pretty simple, huh? Now we can put whatever we want to happen whilst we are aiming. For this, I actually created a line component inside of Unity to create a line between A and B, and of course within the line component there is something called a position. There's actually an array of positions. You of course have point 1, which is the start of it, point 2, which is the second start of it, but you can also have other points, and these points can cater to certain turns that you want to make. But of course, for all of this, I'm not interested in any of it. We just want position 1 and position 2, and we want it on the opposite side of our finger, facing a specific direction. And how do we do this? Well, basically we get the component of the line renderer, make sure that it's enabled as true when we are aiming, and when we are not aiming, it's going to be set as false. Our default position for the line, or the 0 position for the line, is always going to be set at the position of the actual ball, which means it goes from the ball and goes out in a specific direction. Hence why we made the start position equal to this.transform.position. Then we're going to create another variable known as a vector3. Of course, we're going to put shoot position as our name, and then we're going to make it equal to camera.main.screen.to-world point, and of course the point we want on the screen that we're going to translate to the world is the input.mouse position. Make sure that we set shootpos.z equal to 0. This basically puts it on the plane that we are working with. So this next equation is pretty cool. It basically gets you the opposite side of an object. So if our finger's on one side of the ball, we want it to be on the other side of the ball, and that ball's kind of the pivot point. If we were to turn around it, it's going to continue to move on the exact opposite side. We want to get the opposite side. How do we do this? Shootpos is then equal to this.transform.position, or the ball's position, plus this.transform position minus the shoot pos. Now this is all temporary. We are just using this to save a position, and of course we have another variable or vector3 known as end pos, which is basically you have start pos and end pos, which is the start position of the line and the end position of the line. And the reason we have this is to actually create a direction, because we need that direction in order to shoot the ball or add rigid body force to the ball. So of course I finalized this by changing the end pos to the shoot pos. That's basically it for creating a line. It's really cool, but we have when our finger goes down, and then of course we have when our finger stays down, but we need it when our finger comes up to actually shoot the ball in that direction. Of course we've saved our start position, which is equal to the transform position of the ball, and then of course we've saved our end position, which is equal to the direction we want to shoot it at. Now we need something else. We need another method. So we created another method. We called it shoot, with a capital. Of course, once we fire, we set aiming to false so that we are no longer displaying our little line there. And then of course we do all the other stuff, for example, rigidbody.addForce. The reason I used addForce is because using rigid bodies is actually really helpful to get that kind of realistic effect. It's not 100% perfect, but of course we can change a lot of things later in post. This.get component rigidbody2d.addForce, and then of course within the brackets we are going to create a new kind of direction and then times it by the speed. So the way I got the direction is actually to create a new vector2 called direction, and then of course went our start position minus our end position. Of course, start point minus end point is actually saved as a vector2, but also a vector2 for direction. And of course, we just create a public float or speed variable at the very top of our script, and then we can times that by the speed, go into the inspector, and of course change that speed to whatever we see fit. Finally, the only other script we want to learn is to create the new function, which is on trigger enter 2D. And of course, we want to create collisions with everything, so we are eventually going to use sound. When I created the hole, I created a collider on the hole, and then of course I set it to is trigger. The reason is trigger is because if we are going to shoot straight for the hole, but we are going far too fast, it's going to go beyond the hole, and we don't want it to actually hit the hole and bounce straight off. We want it to go directly through, so we have to set it as a trigger, and the way that I detect whether or not it is the right component for this is to go if obday.transform.tag is equal to hole and this.getComponent rigidbody2d.velocity.magnitude is less than our max speed for goal. Now the max speed for goal is actually a float or variable set at the very top of our script, and it basically keeps the speed that I was testing before it gets a bit too fast to actually go into the hole. So I just finicked around with that once I was playing the game, and I was like, yeah, you know what, 0.1 is a perfect speed. Of course, if we hit this trigger, then we are going to start a coroutine or a IE numerator method, which is going to basically drag us to the next hole, which is pretty cool. Within the IE numerator, I basically set everything to false so that we don't aim, we cannot aim, we are not ready to aim, we are not ready to do anything, because we don't want people shooting out of the hole once they actually get into the hole. It then waits a few seconds, I think I set it to 2. Of course, we have some more variables in there, which is the hole number that we are currently at, and then of course we create an array for all the spawn points for every individual hole. Every time we call the IE numerator function, we can create a variable that actually adds to the hole number. Now, because the hole number is going upwards, we can then put the next spawn point and then of course instantiate a ball there, or we can just change the position of our current ball to that position. Of course, we can use an integer as our hole number, then of course link that to the array of game objects or spawn points that we have, and then we can set the new spawn point to whatever the new hole number is. That's basically it. The game should look pretty well, but of course we're missing that one component that we always forget to talk about, which is sound. The sound for this was really simple. 2 of the sounds were made by my mouth, and another sound was made by a cup, and of course a screwdriver, which I have right here. I was just drinking a coffee and thought, hey, what would make an awesome sound? And that's a perfect sound for a ball going into a hole. The other sounds of you actually hitting the ball and hitting the walls is actually made by my mouth going tick, tick, tick. And of course I just cut the sound to be very, very small, so that every time it hits a wall it's going to be like ding ding ding, and of course every time you hit the ball it's going to be like doo. Extremely fun process. I love every bit of it. Of course, if you guys want to play the game, you can find the link for that down in the description. The name is Pixel Golf. Thank you so much for watching. Hopefully you learned something from this video, and if you have learned something from this video, then please consider supporting us on Patreon. We really need some form of help to kind of move to the next step of releasing more videos, and of course getting more people onto the team. Also, you have access to all the scripts, so you can browse in detail of what is actually what. If you want to use them, feel free, man. I'm no copyright here for code, you know. So if you want to find me, you can find me on Twitter. Of course, we have a Discord channel for everybody so that you guys can go and mingle and talk to other game developers. If you guys need help, you can find a lot of help there. There are some fantastic people on there. So hopefully guys, you enjoyed this episode. I shall see you next Sunday where we do the exact same thing again. Different concept, I hope. Bye!